heavy or very hard work or medium category. The physiological workload will be within your limits, but that doesn't guarantee you that the person will not have a fatigue. The another issue which has come when you are having a repetitive movement, joint movements going to extreme level, or you have to maintain a particular posture for a very, very long time. Then another issue which is coming is that mental workload. You are all sitting here in a very, very comfortable position. But when you go out after 4 or 5 hours, you feel what kind of, you will feel exhausted. Although you are not done any physical work for 4 hours. You have been very comfortable sitting in 25 degrees Celsius room, having all workstation within your anthropometric limit. So that mental workload which is coming because you are looking to this particular display continuously for hours and hours together. So that mental workload, vision related issue, you are being asked to monitor something which is going at a speed of 2 meters per second away from you. And after it has reached to 100 meters, you are supposed to know whether that particular system is working or not working, whether I should take a turn or don't take a turn. Those kind of vision related issues are also. You are looking for this particular thing, if I make it a very, very small, half of you will not be in a position to read what is written there. Similarly, reaction time. Something has come on your display and you have to react. Within that time, you have to take a decision. So those kind of ergonomical issues are coming when you are changing your role from operator to controller. So those issues will come. So postural consideration. A fellow is given a joystick in hand or some display in hand, and this person is supposed to control a drone. So cognitive things are coming in the picture, not our physiological workload. So those things has to be considered when we are going to go for the automation technology. So postural assessment technique. Earlier what we were thinking about that, okay, neutral posture should be there and all those things, the joint movement should be within that range and all those things. But you are supposed to go for something more investigative in the terms of posture. You have to consider what is the time of maintaining that particular posture, how much time, how many times this same posture is going to be repeated, what risk it will be there, whether there is going to be a static posture for a long duration. So those consideration has to come when we are going to have a controller based system or sensor based system. Now here you have to, earlier we were only thinking about okay, joint angle, maybe 90 degree or something like that. So now how much deviation it will be there from that? Whether it is in only in one plane or it will be in another plane. Those things has to be analyzed. Not only analyze, these are the different ranges for different joints in different planes. So you have to consider in the different planes how much movement of that particular joint is going to take place. What will be position of your head, especially if you are suppose looking to a particular screen. Your head has to be static for a particular time for a long hours. And if that position is down, so every time you have to look like this. So your back strain will be always there. So that those kind of considerations has to be given. I have just given you all those methods which are basically employed nowadays. These were all based upon the known patterns. Now there are techniques where you are having a computer system. You can take the videos in 3 dimensions, analyze it, how much, which posture is getting maintained for how much time, how much repetition of a particular joint, and whether that joint angle is exceeding the limit which you have prescribed. So those kind of movement analysis is required to be done. Cognitive ergonomics, which is a new area, probably most of us not trained in this particular area of ergonomics. Till the date we were all talking about the ergonomics in that the other way out. Now what is the mental capacity and limitations? That has to come to play when we are going to manage sensor-based systems. So how much load it will give, how much memory it is taking on your human body, whether your motor response will match to it. Any reaction time, how much reaction time you require to do that particular job, to operate that particular control, to operate that particular pattern. So everything has to be taken into consideration. I have just given you what is the complexity, how the controls are complex, what are the technologies required in the mechanization. Okay. What is the, why we are trying to impress upon the cognitive economics is that in controlling you are supposed to take the decision. Till the automation comes, 100% automation comes, you are supposed to take the decision. So that decision making process, you are supposed to do it in a very fast manner because the system is not in your direct control. There is no skill involved that you will put back or you will put clutch or anything. Here, you are pressing the button only will do the job. So those can reduce the load, cognitive load, because if you are having a display where 20 things are coming, 20 sensors are feeding, and you are getting 20 outputs, and you have to take a decision out of level 2 only, and that too with a number. So suppose numbers are coming, 25, 26, 29, 30, and something like that. And you are supposed to take a decision. So if that is instead of that, if it comes with a red mark or green mark or yellow mark, then you can easily understand, okay, it is going beyond the limit of which the system has to perform. So I can take decision faster as compared to the numbers, because then I have to analyze, get the response whether this number is suitable or this is not suitable, whether it is within limit or is going out of limit, like that. So these are the different principles which one has to be keep in mind when you are planning for ergonomical intervention, keeping cognitive load of the human being in this particular process. So these are the different aspects of like user-friendly interface, that whatever interface you are designing between the human being and the sensor or the machine which is going to be controlled, that should be easy to understand, and input, whatever input you are going to provide, which will take action, that providing input should be easier. Second one is the data. That whatever the data is coming, if it is not readable or if it is coming too fast or going away very fast, your sensor may be very, very fast. It may take 100 observations in a second, but the person cannot read, understand and give you a response 100 times in a second. So that data visualization has to be kept in mind. Then automation of repeated activities. Many a time you are supposed to do like when you type in the computers, the repetitively pushing the keyboard keys. So those tasks, how to make it mentally perceivable, so that our mind and hand both can coordinate, or mind and leg, whichever body part is there, that should coordinate. Then minimizing the load which you are transferring of the human being, and ease of learning. Whatever information you are giving, our mind should be able to process and make you learn. These are just, I have just given you example, necessary I understand. Then in artificial intelligence and machine learning, also the ergonomics will play a very, very crucial role. So whatever decision which your mental proposal has to be taken, whatever prediction AI is giving, whether that prediction is understandable, whether the person who is going to analyze it further, whether the AI prediction will be analyzable to him. Similarly, our remote operated, because lot of machines we are designing where the remotes are being utilized. What happens? Suppose a drone is going away. When it is nearer to you, you can visualize its speed. But when it goes farther and farther away, you cannot realize the speed at which it is going. So that those kind of things has to be kept in mind. Right. Similarly, controller, something which is given in your hand. It may have certain buttons, certain displays. If a very small display, you will not be able to realize what is coming out. Then you have to hold it. Maybe 100 gram only, 200 gram only. But you have to hold it for hours and hours together till the time the operation is going on. Similarly, button layout. Then display. Display design has to be taken into consideration. Then eyesight distances I have already told. Then how far you have to keep, how much is the size of that display, and everything has to be. Okay. How many pixels per inch is required, so that human and see. And light exposure. Light exposure is coming from the screen. And eyesight distance, how much your eyesight can distinguish. How much break you have to take in between the working hours. Then post-lateral stress also you have to take care and everything. If you are in sitting position, if you are in a standing position, whether you are using a screen height, control assistant, those different figures are available. These things has to be considered. Then break and rest. Whenever you are using cognitive loading, you have to take this rule 20, 20, 20. Okay? 20-second break every 20 minutes. You have to take out your eyes from the screen or whatever place where you are working. Similarly, these are just given you the what are the possible consequences if you don't take this thing. Thank you. I think I have made my points. In future, we have to do some more work on this to finalize those things. Thank you. Thank you.
Thank you, everyone. So we are fortunate to have Dr. C.R. Mehta here, who is Director of Central Institute of Agriculture Engineering, and Dr. S.K. Singh, Project Coordinator of Animal Mechanization. So I'm thankful to you, Dr. Agarwal, for covering the whole ergonomics and the new aspect of cognitive ergonomics, which is still untouched. And people are working on robotics and mechatronics, and they will need this input. So it was really an enlightening talk, which I'm sure that everyone is benefiting by. Now we'll quickly go through this list, and I'll request the presenter to confine to 5 minutes, because the number of presenters are more and we have a time constraint of 1 hour. So Shiv Kumar Lohan, Mahesh Kumar Naran, Santosh Kumar, the first paper is pertaining to cognitive problems. Real-time virtual interface of remotely controlled two-wheel transplanter. We also have to combine the second paper also along with it. So the second paper is development of real-time human touch analysis using a computer vision-based classification. Yes. So this is a different kind of pressure which Dr. Agarwal is discussing, so he has not covered that, but yes. So Dr. we have 5 to 6 minutes.
For both.
Yeah, for both obviously, but I told him in the beginning.
Speaking mic. Actually, mic आगे आता है.
Delegates and colleagues. First of all, I thank you all. So most of the work related to ergonomics has already been defined by Dr. Agarwal. So I have kept only one component. So we have developed the remotely controlled two-wheel system, a two-wheel cardiac transplanter, and now we have developed the real-time virtual interface of operating this system. So this is the background. Already we have in Punjab 3 types of cardiac transplanters are there, and their area as well as their numbers have been increased since last 1 decade, and these are some of the constraints and issues which are existing on existing work transplanter. For example, the worker has to work in the high temperature and the high relative humidity, and he has to work in water-filled condition up to more than 20 km. And some other issues like he has to work within 30 centimeters of the width of the soil. And like catwalk, during this catwalk, strapping means when our thighs are contacting with each other. So these are types of problems has been noted during our previous study. So, this is the existing control panel of right transfer. For example, this one is accelerator, right steering lever, and left turning levers and transplanting phone stop. So we have fixed the motors wiper motors instead of the manual clutches, and these motors has been operated by the PCB and remote control. So this is we have already developed, that is the only two-wheel remotely controlled for two-wheel precise transporter. So this system has been developed, so we can just have a so here you can see the running of this machine. So operator can turn this machine sitting outside the field. So it can be turned at 150 degree if operated precisely. So in this way, so operator can operate this machine. So these are the 6 levers. We have fixed the gear motors. Then we have fixed 2 cameras, front and rear, and these displays can be viewed on our computer screen. So before developing computer screen, we have attached on the personal goggles. So then we found that after 15 minutes the operator was headache. So that's why we put that visualization on our directly on computer screen, and this is the design of our handheld remote control. So as Dr. Gawal said, the ergonomics design has been kept consideration in mind. So for example, left and right is the most used button, so that's why we have used this left and right in our right hand, and then the other most probably use is the transplanting on and off. Because after every length of rope, we have to stop the transplanting. So the display and controls we have designed according to the ergonomics designs. So here you can see the path navigation on our computer screen as well as the real-time visualization, and the video has been received by the video receiver, and we are controlling this through remote control. So yes, sir. Okay, so here we can see that the simulation of while operating this transplanter. So we have collected the data at 3 different power speed and 3 different working hours, and mode of data has been compared with the existing transplanters. We are actually on 10 subjects. So so I will just skip these. So how we have calculated the root mean square errors and field capacities and the response time of each controls, and we have also obtained the data on the postural and physiological response. For example, reverse score is very high while using existing right transplanter, and by using remotely controlled, the reverse score is very less. Similarly, overall discomfort score and is very less while the operator is sitting on the chair, and energy consumption is also very less as compared to the existing mark behind cardiac transplant. So we have optimized the forward speed with about 2.12 km per hour, and so here we can see the effective field capacity is also increased at higher forward speed, but at the same time field efficiency has been decreased. So this we have already optimized, and this is the comparative evolution of labor requirement and fuel consumption. So thank you very much, sir. We acknowledge the NSRP on GISA, Malaysia, Nahid project, and Washington University, in which I got the opportunity to spend 5 months during my in-service period. And this one is the T&D electronic system which we have collaborated with this manufacturer. So thank you very much.
Thank you.
This is my first presentation, and
Second, you can just say,
Dr. Mohan, you have shown this operation
yes,
and you have followed going and coming.
yes.
And in that case, the headline was too much and then left was too much.
Sir, actually, what happened when operator is operating the machine? So earlier we could not see the how much headline we have to tap. But with the virtual interface, when we are installing the cameras, so for example, here you can see. So now we can reduce the this one. So now we can reduce the headline. So we can imaging. So with the help of this virtual interface, we can reduce that. Earlier it was not possible when the operator is operating the machine by remotely controlled and by seeing physically. So that was the. Now with the installation of cameras, then so we can utilize the how much pattern we have to utilize.
The pattern can also be decided that what pattern would be best.
Yes, sir, we have already tested with the samples. Yes, that we have also tested. We are working on that also. So thank you.
Sir, I have a request. It's already 10 minutes. तो अगर आप दूसरे को सिर्फ उसके conclusion दिखा दें तो
सर दूसरा का सर बिल्कुल थोड़ा सा वेरी फास्ट फॉरवर्ड करूँगा. We have got the real-time post analysis of based on the
इसके आप results ही दिखा दीजिए.
सर बिल्कुल रिजल्ट से दिखा रहे हैं सर. So actually ये economics से apart posters and Dr. One has already mentioned it. So by for metering we have the method two methods, one is indirect and by using a questionnaire, and another methods for the ruler, REBA and OAS etc. So this is the REBA method. So for measuring the posture evolution, in this we have to measure the body posture angles, and then we have to measure the score, and on the basis of score we could finalize so for this we have to measure the angle with the angle of Memoria software. So now we have got the real-time software. So in which we can browse the input image or video, or we can use the live camera. So then we have processed the motion data, and then we can measure the joint angle calculation by default, and then we can determine the angle score, and on the basis of score we can determine the reverse score. So this is the 33 points which this software can find out, and in 3 dimensions also. So for example, you can see here this is a live video, and this software is analyzing the different 33 points and also measuring the angles. So this is our first objective, and then this is the software. So you can see here here you can see that we are browsing the any one pics. So then after pics or video, we can select here the body frame landmarks, then score 100. For score 2 calculation, we can observe that the change in the angles, and finally change in the REBA score live. So here with the change of REBA score, as Dr. mentioned, it should be the color basis. For example, it goes up from more than 8, then it will red, and then if it is less than 4, then it will green and yellow. So finally we can save this data time per frame, and this is where you can generate report. If you are using the still image, so we can generate the report of all the angles and scores. So we have validated this software by using the 3 measuring methods. First one is the REBA direct sheet method, second one we have used the Excel program, and third one is our software. So we have used that 27 pics, and for this subject, for example, it is 9 pics are the operator is using the statistical for cutting the net time nursery. This one is the indigenous nursery cutter by the operator, and this one is we have earlier developed PA nursery cutter. So these 27 pics were utilized for validation of data. Here you can see that by REBA method this is non-significant, and the other methods are found significant. So non-significant means our software is have the same results as per the other methods. For example, here you can see the PA software, Excel program and REBA sheet. So this is almost 100% same. But sometimes our software gives the other value. So that might be because this is capturing the real-time points for measuring the angles. For example, by using the net angle, so we have the category of 0 to 20 degree and 20 to 60 degree. So our software observed this value, for example 21.5. So when we are measuring that angle with the help of Kinobel software, that might be 19.5. So that will fall in the different range. So this type of, so here you can see that the for final reverse score, which is the looks same reversal program. So thank you very much.
Thank you, Dr. A very good presentation. I suppose this software which you got can be
Yes.
disseminated to other centers and they can
Sir,
also use.
sir,
Any question, any remarks for Dr. Rohan?
एक चीज है सर,
Sir,
it's good, very good, it is needed. And my question is, in a river
Yes,
or
sir.
ruler, there is a duration.
yes, sir.
If you see this basic rule, so this is measured for particularly if that posture is up to this much duration. So if in your software,
Yes, sir.
if you also put that
Okay.
duration,
Okay, so that duration we will measure and
and then it goes to the radar like this, then it will be much better.
so if you see this this graph, so this is the for example this is the data of 176 seconds. So here you can see initially for up to 8 seconds it was 9 and then again it goes to 10 and
It is not like this. When these scores suggest
yes sir.
if the same posture
Okay.
is maintained for this much period, then only this allowed. This is to be
You
done.
can consider the
Otherwise, it should
Now
not.
you have considered
You
it.
can take into consideration joint angle, particular range of recommended joint angle, and that how much time it has been maintained under that.
If you incorporate in this, it is a good, very good, I think.
That's
That
very good.
normally doing, people are using, but not that good.
सिंपली एक जॉइंट एंगल निकाल लेते हैं और
Yes, sir.
वैल्यू दे देते हैं 035 जो भी है
और
That is not right.
Okay, thank you. Thank you for excellent presentation. So next, I'll keep my presentation in reserve because other youngsters are here and we'll give a chance to them. Sergio, physiological workloads among dairy farm workers.
There is
And it is the co-author is Dr. Kendra. Yes. So you please.
Good morning, Chair and Co-Chair. Myself, Sir Topram. I'll be giving presentation on the topic physiological workload amongst the dairy farm workers. Dairy farming is one of the top milk production unit all over. India is one of the top milk production unit in all over the world, and it produces 25% of the global milk production. And workers in the dairy farm work for 365 days for like 24 hours, and they perform various tasks, including cleaning, feeding, and the rest of it. And these tasks are mainly performed manually with some basic tools. And there are no studies on physiological workload in dairy farming. So I created two objectives to fulfill the gap. First is to measure the physiological workload among the dairy farm workers, and second is to get a better severity of workload. I have selected three farms, three commercial farms in Arunachal Pradesh, and I have selected three tasks, that is feeding tasks, the cleaning tasks, and the milking tasks. I have selected 30 workers, 30 male workers under the 36 to 60 years of age, who are physically fit and has an experience of 1 year in the dairy farming activities. I have measured the heart rate, I have calculated VO2 and ER using NAP et al. Equation, and I have categorized the severity categories. using using the HR by Burgess and Oxygen Gibson by 1980 and energy expenditure rate by Navigator 1980, and I have done the set analysis for the ANOVA. The working heart rate while cleaning activity is 113 BPM, and for feeding activity is 121, and for milking is 105. In here, the working heart rate during feeding is higher than the rest of the activities. Similarly, for the delta HR, and for the VO2, similarly for feeding activity, the oxygen consumption is more than that of the cleaning and the milking activity. For the energy expenditure rate also, the feeding activity is higher than that of the milking and cleaning activity. The task has significant effect on the HR, VO2 and the ER, meaning that based on the task, the energy expenditure rate will be changed. I can conclude that based on the work specific characterization, that any activity is categorized as moderate based on HR, based on HR, the activity is categorized in heavy, moving as light, whereas for the based on oxygen consumption in ER, the milking and feeding activity is categorized as moderate activity, and moderate tasks and feeding activity as a heavy task. These are some of my recommendation. Thank you for listening.
Thank you.
No, one thing, you have taken the subject age,
Yes, sir.
36 to 60.
Yes, sir.
Did you recommend it is your study? It will be up to 35 by 60 is
Just whether all the dairy where you have collected this data, whether the number of animals were same
It's
or
almost
means working environment was same. How you maintain means you are basically measuring physiological levels.
yes, sir.
So then the working condition for all the treatment should be same. Otherwise there will be a variation because of the environment, because of the number of animals, because of the activity itself. So how you maintain that uniformity of that activity?
Sir, actually, the farms that I have collected data, those are all government farms. They have their own protocol how to be like kept and how to be like working. So it's same only, sir.
What about the duration of this milking period?
It's there are two shifts, morning shift and afternoon shift. In one shift around 1 hour to 2 hours.
One person is milking for how many
Yeah,
times?
1 hour. Two
20
times.
hours?
Yes, sir. Two times a day. One shift is 1 hour.
Yeah. Government forms, so they have a protocol.
Every day, every person 4 minutes is program में 1 मिनट को गाय milking करने.
There is not only one guy, sir. There are cows, sir.
number
There
of
are like
cows.
20 of cows, sir.
एक घंटा का duration.
That is what I भाई
very
जो आपने वर्कलोड है उसको कंसेंट कैसे रखा? डेयरी इज सेम तो ठीक है कि आपका वर्कलोड कांस्टेंट
Duration of
same
measurement.
amount of milk is coming, same amount of
Target measurement
I
duration.
measured for resting for 5 minutes, then 30 for working hours, then again 5 minutes for recovery, sir.
Thank you.
Thank you, sir.
So we have Tabi Tala. Sorry, I welcome Dr. Rasen Khan, ADG Engineering and President ISA. We should take care of it. To be here in the session. So we are privileged. Tabi Tala.
So he's online. He's online.
He's online.
Yeah, online.
Can we start online? Next week. आगे ठीक है फिजिकल
Secretary. Next is Secretary, Surya Kumar.
Surya,
You have two.
Yeah.
presentation and your definition 5-6 minutes.
Please, sir.
Please.
A very good morning to one of our respected chairpersons, directors and other dignitaries. My name is Surya Chetri. I am presenting a Professor K. came here presenting his paper, the development of model to estimate oxygen uptake of rational voltage in remote area. There are different estimation models to estimate the volume of oxygen consumption. Tiwari and Gite et al. They mentioned that the measurement of oxygen uptake in the field requires sophisticated instrument and a technical expert. Because of this, many authors have developed a model to estimate the volume of oxygen consumption in the using the heart rate. Some of them are not at all 1981, Tiwari and Gite 200. 2010 and Gite 017. But this may not be feasible for the northeastern population because of the distinct features of the northeastern population, and also there is a variations in the climatic conditions, food habits, and the geographical location. Because of this, anthropometric dimension of the northeastern people may differ as compared to the other central and other population of the Indian. For this, we measured the heart rate for 168 subjects from 8 different rice mills located in Assam, and the selection criteria were free from MSGs and at least 3 years of working. We measured the heart rate in the rice mill by load carrying, and the oxygen uptake was measured in the laboratory using submersible tests. We did the submersible test, and we follow the Norton's protocol. We develop a model. We follow the PLS method, and the input parameters. We input the age, working heart rate, stature, the mean working heart rate, stature, body mass, experience, the environmental conditions like dry bulb, temperature, wind speed. So in the PLS system, the VIPs the 0 were eliminated, and the model accuracy was also calculated using about 2018. So what we found that during load carrying the rice means there was a cyclic pattern of the heart rate. As the worker was carrying the load, the heart rate increases, but when he's coming back to the loading station without the load, the heart rate decreases. So if you can see here, there is a cyclic pattern of the heart rate. And also we measure for different tasks, for 7 different tasks in the heart rate for the 7 different tasks in the rice mills, and these are the results. Therefore, also the oxygen consumption, we found out that the volume of oxygen consumption was equal to 35% of VO2 max. So that means we need to develop some walk-rate cycle, or we have to develop some recommended load. So we try to compare the different models developed. So we found that all the models underestimate it. The oxygen consumption for the northeastern people were higher as calculated from Tiwari, Nav, and Gite et al. So this is the final model which will be used for the northeastern region. We found the R-square of 0.86. The only parameters which was included was the found base was the working heart rate. This is the final model. So this model can be useful to estimate the VO2 for the northeastern region population. Thank you. Question. We are going to compare the physiological response for load carrying on head and neck. So the workers carry the load carried on the back and the load carried on the head in the rice mills. So there are different MMS tasks in the rice mills, and the paddy bags usually varies from 32 to 56 kg, and the rice bags usually are 10, 5, 10, 25 and 50 kg rice bags. The workers work in the upper portion. They have to walk above the stairs of the paddy bags to reach the final point for the locations. So again, physiological response depends upon the surface characteristics, the weight, load, type of load, and the working speeds. So for this, I have selected 12 rice mill workers from 8 different rice mills. I have measured my independent parameters of working speed. I fixed at 0.61 and 0.89 meter per second. The load carried by the workers in the head of the deck, in the head and the deck was 40, 50, and 60% of their body weight. The mode of load carrying was on the deck and on the head. And the surface inclination I kept constant as 0 and 5 degree. So as dependent parameters were the heart rate and the VO2. So I tried to calculate the recommended weight limit, how does the workers should carry. So I measured it based on Saha et al. 1971. There is a 35% of the VO2 for the 8 hours work shift, and Wu and Wang 2002 there is 45% of VO2 for a 4 hours work shift. During peak season, the rational workers usually work for 12 to 14 hours in a day. So what we found out, the physiological response for load carrying on the head was higher as compared to load carrying on the back, but it was not significantly, it does not significantly vary. Similarly, when as the load increases, the heart rate and the volume of oxygen consumption also increases. Similarly, we get for the head and the back, and similarly when the speed increases, the physiological response increases with the speed of the back. So here what we did is that this is the major part. This is 40, 50, and 60% of the bullet. We interpolate and extrapolate it so that we can find the recommended load based on 35% of VO2 max and 25% of VO2 max. We measure for different working speed and for different mode of load. So what we found out that the workers should not carry load higher than 52.6% of the body weight for a working of 8 hours. That is 29.3 kg should weight. And similarly, the minimum the transition for load carrying on the head and 0.8 and we're walking with 0.8 meter per second and a rate of 5% of the work is recommended the workers should not carry any load. Similarly, for 45% of the VO2 max, we found out the maximum load to be carried varying from 41.3 to 39.3. As per these Maharashtra factory rules and Kerala factory rules, the adult male workers should not carry a load greater than 55 kg. These are all that's 1971 Maharashtra factory acts. So I want to conclude that the recommended load should not exceed 52.6%, that is 29.3 kg for 8 hour work shift, and 74% of the body mass, that is 41.3 for the work shift of 4 hours. Thank you.
Thank you.
No, but you have not mentioned the duration, the distance. Speed doesn't mean if distance is increasing.
Yes, sir.
If the load is taken by for 50 meter, 100 meter, 5 feet.
Sir, when we were measuring this one, we found that the loading station to the vehicle, the tail of the vehicle, we cannot make it constant because different.
There would be at least 2 meter, 5 meter.
No, sir. According to my time motion studies, I did a time motion
What's the steady state? आपका load constant है, अब कितना रहना चाहिए?
Yeah.
Previously, people were lifting 100 kg of.
Yes, sir.
It was reduced because of this.
Yes, sir.
And the literature also says that if you are lifting only 20% per head,
Yes, sir.
50%, this is a free ride. You are not.
Yeah, free ride. Yeah, sir. What in my case, I found free ride of 40%.
40%
Yeah, because of this, they are limited in road carrying. So I found 40% was a
Any other research?
Yes, sir.
You have tried 45% of VO2 max.
Yes, sir. Yes, sir.
It is recommended that we have to take 35% of
Ah,
VO2 max.
is
You take 45%.
Sir, 35 for Indian conditions, I in 1971 said 35% of VO2 max for an 8 hours work shift. But in my case, like a worker is carrying for 4 hours the load carrying, and again he is doing some lighter work, like he is feeding the rice or he is feeding the huts. Then he is not carrying the load carrying tasks. Because of which I took a condition of 4 hours work shift, that is 45% of VO2 max. Many authors even will go with 60% of VO2 max for 2 hours work shift.
Rather loading, carrying the load,
Yes, sir.
particularly bags.
Yes, sir.
It is not possible to maintain uniform speed or walking speed.
Sir,
It depends upon load as well as distance
Yeah, yeah.
to be carried, that
Type of
load has
carrying
to be
also.
carried.
So I did time was study for 168 people. So what I found out that I took the average, I took the lower grade, and I took some review and also how much the persons are working with this one. So my average load, average walking speed was 0.82 meter per second. Then when night is that.
Yeah. It varies from person to person.
Yeah, so this is data for 168 people.
Okay, good.
Good.
Thank you.
Thank you. So now we have CMD's online Rahul. So Rahul Raja Bota, co-authored by Syed Imran, Vikram Jyoti and
here. So in grape cultivation, many operations which are carried out that has been carried out by female workers and particularly manually using conventional tools and equipments. So
You skip introduction.
so desuckering is one of the important operation which has been carried out in grapevine cultivation. And here the suckers that has grown at the rootstock are removed with the hands, but particularly which is carried out manually by the female workers and in the bending and sweating posture using the traditional secateurs. So many times these females has to adapt the upper postures and in the long run, if they carry out this activity, bending and sweating, there will be a postural risk and in long run there will be MSDs in them. So considering the various ergonomic and anthropometric principles, we have developed this desuckering device which enables the farm woman to carry out the desuckering operation in standing posture particularly. And this equipment is consisted of a brushless motor, DC motor, which is powered by lithium-ion battery, which is a lightweight. The benefit of this device is the posture of the worker is improved. So the developed device we have ergonomically assessed. For this assessment, we have selected 12 female workers which are having experience in carrying out activities in grape cultivation. And for this assessment, we have measured the physiological parameters with using the polar heart monitor and other equipments. We have measured the discomfort parameter, that is body part discomfort score, using the correlated Bishop discomfort measurement protocol. Then we have captured the images and videos for this assessment of the rapid antibody score. And we have also assessed the classified the workload in traditional practice and with the development intervention. So if you see the results, the physiological workload, say working heart rate, which is lowered in case of developed interventions, that are 20 to 30%, and work pulse, and then oxygen consumption rate, VO2 max, which has also found to be lower in case of developed intervention. And also the based on these parameters, we classify the workload moderate with the intervention as against the heavy or very heavy in case of this traditional practice. Also, the worker output is also increased by 40%, whereas in traditional practice, the worker covers 40 to 45 wines per hour. With this device, they now they will cover to 110 to 125 wines per hour. So also in case of the discomfort score, we can see that in case of traditional practice, number of upper body as well as lower body parts get painful. But in case of developed device, only these painful body parts were reduced. Due to which the body parts discomfort score also reduced in case of developed intervention. And most importantly, the REBA score has reduced to 3, which is a bit in comfortable zone. So in case of traditional method, sorry, here is so now I'm concluding that with the developed intervention, the posture of the worker has improved, and the also output of the worker increased by 40%. With this intervention in this desuckering operation, which addresses the issues of discomfort and safety of the women workers in grapevine or orchards.
Thank you.
Okay, sir.
Any question? Any? So we have हमारे साथ या भूषण जी को बुला लेते हैं, आप कर लीजिए बात। डॉक्टर भूषण बाबू co-authored by Dr. Podar, Dr. Agarwal, Dr. Patel and Dr. Sorry, your name was not there. Dr. अच्छा गजेंद्र सिंह, Dr. प्रधान, साहू and Dr. V.K. Tiwari.
I'm some new जीरो, so I will begin.
तो आप तो इंजरीज के ऊपर बताएंगे तो जस्ट शो द कंक्लूजन्स।
How long this session is to be continued? Around 10.
10 के आसपास खत्म कर रहे हैं। तो ये ऑनलाइन भी है कुछ लोग हाँ भी कर रहे हैं। तो we have to skip everything. Just go directly to the conclusion. What are the conclusion? You can show. IIT Kharagpur से।
Abhinav Kumar.
Abhinav Kumar, he is in place of Dr. Gajendra Singh. So he is making a presentation of the paper from IIT Kharagpur.
Good morning, everyone. So today I am going to present the accident using machine learning in accident prediction. So we had surveyed the accidents in West Bengal in 3 districts, and so these are the results. So this table shows the demographic and agricultural details of selected districts, and other table shows the status of mechanization in selected districts. So and this table shows the source-wise classification of accidents. So this graph shows the accidents place distribution.
पढ़ने में नहीं आ रहा है भाई यार। मुझे बढ़िया टेबल दिखा दो, ठीक है टेबल में ठीक था, बताओ पढ़ ही नहीं पाओगे, जरूरी है कि एक में ही चारों रखो।
Recently joined coach है, understanding है।
नहीं वो संवाद भी तो
Sorry, sir. So we use various ML models, and we compare the ML models as per the accuracy, as per the precision, as per the recalls, as per the urban score, and as per the AUC. So what is the precision? Precision is the true prediction value. It is a ratio of true prediction value to the sum of the true prediction values plus the true false prediction value. So here we can see that the decision tree model has the highest. It was shown as the best model for the precision, and for the recall again the SPM showed the best model, and for the F1 score means it is the harmonic sum of the precision and the recall, and this F1 shows all the models show the similar results for the F1 score. And for the AUC is the area under curve, which shows the which basically difference between the false cases versus the true cases. So it is the random forest shows the best results in the AUC, and for the important feature, so there are various important features, and the reason was they found to be the most important feature for the machine learning algorithm, and followed by the classification and cause of the accident. So the conclusion matrix shows classes the accidents into 2 classes, non-fatal and fatal, and our model predicted 150 fatal cases, and where it was not that good confirming the non-fatal cases, as it only detected the 1 non-fatal cases. So coming to the conclusions, the agricultural accidents in West Bengal vary by the mechanization level and gender, with farm machinery causing 34% of the incidents and hand tools causing 27% of the incidents. And Jalpaiguri has the highest accident rates, 42%, with men more at risk from machinery and fatal tractor accidents, while women faces higher risk from hand tool injuries. And the random forest proved to be the robust model with high AUC 0.71 and precision 0.87 and accuracy 0.91, and identify reason and cause of accident as key predictors of accident survey. The random forest model demonstrated high accuracy in predicting fatal accidents with minimal misclassifications in non-fatal cases, making it a reliable choice for accident severity prediction in agriculture. And it also insights could help to target high-risk factors to enhance the safety and protection in accident cases. So the future scope we want to do is we will collaborate with the local agencies to implement this targeted safety training and awareness program for the high-risk groups, and we are aiming to reduce the agricultural accident rates and improving safety standards sector-wide through data-driven insights. These are the references, and at last I would like to acknowledge the ICR and the ACLIP is a project, and also IIT Kharagpur for doing this research. Thank you.
Thank you for this presentation. Any comment or any question?
Just one
Yes,
question.
sir.
In the conclusion you mentioned accident rate 42%. What does it mean?
So accident rate 42%. So basically it came from the accident incidence rate. It may be from per 1 lakh worker per 1,000.
You didn't mention
That
anything.
was
You
the
mentioned
same,
That's what I want to tell. What does it
रेट
mean?
और परसेंट में अंतर होता है.
Incident rate is different. That means for 1 lakh was
One,
10,000.
What is the rate?
It is percent. 100 में.
1 lakh workers.
Per 1,000 to
5
half.
years, 10 years.
Point 0 something like accident rate per annum.
No, you should be careful. Okay, thank you. Dr. Bhushan Babu, Dr. Shobana, Dr. Agarwal, Dr. Kishan Kumar Patel, and Deepak Tiwari are studying on agriculture accident and centering.
Very good morning, everyone. I'm presenting a study on agricultural accidents in central India, analysis factors contributing to the estimation. We understand what is the importance of machinery and how the accidents are being caused due to the improper use of the machines. So authentic data is required to measure its logistic estimates. And this is a brief review of how the accidents were happening in the previous years. Like fatal accidents has constantly increased from 9.2% to later on 12%, and now it is 20.2%. So this is how in 2004 and 12-13 it is 333 accidents per 1 lakh workers and 374 accidents per 1 lakh workers. So the material methods that we used is we have conducted a survey and we have developed, we have transformed the paper into to the app collection. So we developed a web application through an Android app, and we use the softwares like Android Studio, Adobe Dreamweaver, and for database we used MySQL, then we have we use the CDS and Eclipse for to have the data on the server and current data, see what is the data and then doing the analysis. So we did the estimation procedure by using the simple estimates. Then this is how we enter the data to the web app, and then we do the analysis backend. And this is some of the screenshots that I'm just skipping, and this is how we monitor the data. So this developed app helps us to monitor the data if there are any corrections which was not possible through the manual method. So this is how we monitor. If there are any mistakes, we use to correct, and then we update. Coming to the results and discussions, that we see that the accident incidence rate is at present it is 2.94 per thousand workers. Then farm machinery it is 2.28. We these are the slides of our training, and if you see that altogether we have 182 accidents recorded. This is an accident incidence rate, is 2.94 per 1,000 workers. And if you see the farm machinery, the accidents due to farm machinery, it is 2.28 accidents per 1,000 farm machinery. Now, the importance is that we are trying to see what are the how many number of accidents, but how it is happening, what are the reasons. If you see that it is how where if you see that more than 90% of accidents we see recorded in the field or farm roads. And the number, what are the accidents or what are the machines that are contributing or given here. The major contributors are the tractor, thresher, and electric motors, followed by chaff cutters. And further, there are other accidents that are contributing around 20% also. Then coming to the tractor accidents, what are the reasons? Many of the reasons that we found first see is due to ignorance. Then you see the thresher accidents, lack of safety devices is the major contributor for the accidents due to this. Okay, this is for the cultivators. Then for the electric motors, again, the faulty equipment is one of the reasons. And if you see them in the field, it is open electrical boards that are the major cause of accidents here. Then chaff cutters, the major reason is ignorance because of most of the children are exposed to this kind of accidents because we lack BIS standards in followed by these manufacturers like the covering of the blades or the or not having the locking system mechanism. This is causing the accidents in this. And if you see the handles, it is 0.14. And the major reason here is tiredness and improper workplace. And this is for the others, it is 1.47 per 1,000 agricultural workers. And the major reasons are the snake bites that we see, but we generally ignore it, but we need to do something for this or to develop some kind of a protective character for the workers who are working. And if you see the reasons or cause of these accidents is first 2 to 3, we see that first is an ignorance and followed by slips and falls, and the lack of safety devices is a major reason for these accidents that we found. Gender-wise, it is accounted 80% and 19% female. Fatal, non-fatal. This is the major thing that we are observing because we have done intensive survey here. So we found that the number of accidents is a percentage increased to 20%. Earlier it was 12%, and before that it was around 9 to 10%. So finally, I just conclude. Okay, this is an estimation. One more before concluding. If we estimate that what are the losses, it is 12 crores, out of which more than 99% contribute to the fatal accidents. This is one more thing that we need to see. So we need to reduce the number of fatalities in accidents. So to conclude, total number of accidents is incidence rate is 2.94 per 1,000 agricultural workers. Monetary loss, I have already told. And the major accidents are due to the ignorance, lack of proper training. So training is important for to make people aware to save their lives. Thank you so much.
Thank you. Any question? Dr. Sir, I have only one thing to ask. Can we attribute ignorance as a causal factor?
Cause of the accidents? We have to answer the fact here, sir, because
we are doing the research and we are giving some causal factor.
no, that's why we need to make them aware of the things because
We make the machine safer, ignorance doesn't come into it.
no, even then we cannot stop the accidents if they are ignorant of the machines.
Normally,
See, suppose I'll just give you an example. If we put a sensor system,
Question is good. Actually, if someone is ignorant or not aware about that proper operation of that machine, he or she should not operate.
Yes.
In
Yes,
principle, it is
yes.
expected. But sometimes it may happen that someone may be
This
operating without knowing
point
it.
was good, but word word needs to replace the word. Ignorance, some other words you can.
Anyway,
Okay, excellent.
thanks a lot for the excellent presentation.
Okay, thank you so
So
much.
we'll have another next presenter, Dr. Awali. You're here. So Dr. He's going to present on e-powered petty transfer.
Yeah.
What's up? We have a time constraint. 4 minutes.
Good morning. Here Mithana, Singh sir, Nandalawan sir, chairman of this session, Adesh Kumar sir, reporters, Senthil Kumar sir, and all scientists. I am going to present the research work on minimizing drudgery and work strain with e-powered tag transplanter. So this type of transplanter we have developed. This one is root wash type transplanter. So with the regular testing, it has been found that there is back pain for the workers. So we studied the biomechanics of that, and depending upon the biomechanical study, we made the changes in the tracking system. So this is biomechanical modeling we did. So we have found the forces acting, horizontal force, vertical force, and also the moments acting on the lumbar vertebra, L4, L5. So for finding the biomechanical, finding the moments, there was need to have the body segment length. So this body segment length were approximated by using the, so they are
This one, directly what intervention you have made to reduce the comfort, drudgery of the worker.
then this is body segment weight has been taken from this, and the relative location of the center of mass is taken from this. Then the angles are taken using the Kinevere software. Then the force is required for pulling and relaxation we remained using the road shape. So we develop this force measuring setup for that. We have got the design base station. So this we develop, we have got design base station. This sir. We develop the force measurement setup is shown here the photograph. So this is the complete was the experiment. So these are two camera profiles we took, three floors data, and from that the different parameters where the cranking force, pulling force. So these are the two types of cams and three types of floors we took.
You directly go to the what intervention you have made.
फाइनल आप डाटा दिखाओ और उसका वीडियो दिखा दो आप बताओगे
Video में जरा click करो. So this one is the transplanter we have developed previously. So this is walking behind type. From the biomechanical model we have found that so there is force coming on the back and also the neck joint. So we made changes. We have eliminated the cranking operation, and in the next video you can see the cranking is eliminated and the person is only guiding, and so the drudgery is reduced.
Then you develop remote control.
Nice.
इसका पार्ट
So here with horizontal force coming on the joint L5 joint is here 61% less with the developed transplanter. Vertical force is 7.4% less, and the moment is increased by 6.4%. Then compared with this thing newly developed can with the curved wooden float has the less pulling force and the cranking force. We did ANOVA also, and we have found cam and float. I mean, the effect of different types of cam and float on the pulling and cranking force was significant. with the wooden float was significantly less. We did the Turkey comparison test, it was significantly less. Then these physiological parameters were at par, but the overall discomfort rating, body part discomfort rating, also energy, the grade of work were less with the power transplanter, and speed capacity is 24% more. So we did this. So physiological parameters were non-significant, and working heart rate, delta HR, and also ER were non-significant. However, the body part discomfort score, overall discomfort rating, and field capacity were significant, which are less in the E power. So this conclusion that the force on lumbar vertebra L4, L5 in horizontal as well as vertical direction were found less. Also, movement was less. Missing heel were 50% less compared to the existing. Field capacity was 24% more. And here the conclusion: the developed power transplanter is found suitable for paired transplanting using root or step seedlings with enhanced comfort and field in this field capacity. So these two articles we made, these are in the pipelines. So from this, we are going to file patent also.
Thank you, Racha.
Sir, I want to tell one line only, and I will finish. So brief vakya of this university is Krushi Moolanam is Jivanam. Means farming is the foundation of the existence of human being. So I mean, when farming is there, farmer is there. और फार्मर के साथ में हमारे स्क्रिप्चर में ये भी आता है सर कि श्रम कृषि मूलनम। अगर श्रम का मतलब कृषि का जो लिंक है वो श्रम के साथ में है, तो श्रम है और कृषि भी है, फार्मर भी है, तो हमें अल्टीमेटम वी आर डूइंग द थिंग टू डू द कृषि ही सुकर्ष मूलनम। इसके लिए हम सभी लोग इसी तरफ बढ़ रहे हैं सर।
इसमें एक चीज बहुत समय एक चीज है कि आपके रेलवे स्टेशन में मुझे ICR भी
है सर लोग
साइन किया
है लोग
रजिस्ट्रेशन वाले सर्टिफिकेट
ICR का नाम है सर नहीं सर।
Thank you, Racha. So we have online presentation. Please. Where is office? Ergonomically designed, manually operated, Loknath cutter holder.
just show us
Show the product and the
Good morning all of you. I am presenting on behalf of the Dr. Isham Malawade and team. The topic is development and consolidation of manually operated Okra cutter holder. The main aim of the main aim of the
जो बनाया
आपने इक्विपमेंट दिखाइए वीडियो को दिखा रहा हूँ।
this is the developed Okra cutter, that is length is 100 and width is diameter is 40. This is a collecting rack which is used for collection of okra. The main aim of this project is to reduce the allergic reactions and reduce the force for cutting. So force required for cut the okra is approximately 12.63, and for manually operated by hand is approximately 50 Newton for male and 35 Newton for female oaks. So this is a heart rate measured at the time of evaluation. that is average ODR is 2.3, that is no discount, and VPDS score is 18.70. I am going back to conclusions. So develop product force and overall force of weight 168 newtons, and heart rate of the subject during the operation of pump of 95.23 beats per minute, and energy expenditure rate is 12.17 kilojoule per minute. That is BPDS is 18.7, ODR is 2.3, and the cost of operation of Cobra is just 22.1 rupees. And the harvesting per hour is 50.22 per hour, which is more than the other competitors. So there is one video. ओकरा उसके अंदर चलेगा।
दूसरे हाथ में लगता हो, एक हाथ को आप बचा लिए तो
लेकिन दूसरे हाथ से प्लांट पकड़ने से
गवर्नमेंट कार्ड
होते हैं भाई, देखो नहीं आप
अगर इस हाथ से काटेंगे तो ज़्यादा इस एलर्जी
जो दूसरा हाथ पकड़ रहे हैं उसमें क्या वो नहीं लगता उसमें बिना पकड़े बिना
नहीं वैसे वो कर देंगे, वो कोई असर नहीं हाथ में लगता है।
एलर्जी
ग्राउंड नहीं कर सकते क्या? ग्राउंड
समस्तीपुर
वो जो है उसमें फंसने की फंसता है कि नहीं फंसता है, इसका सब्सटेंस होता है ना ग्रुप में स्टिक सब ले बहुत पहले हुआ
50.22 per hour.
540 ओकरा पर घंटे।
नहीं
सर मैं वो देख रहा हूँ कि इनका जो आवृत्ति कॉस्ट है
बेचारा ओकरा 6 पॉइंट ओकरा की स्टीम मजदूर आती है
5 रुपए की जो हमारा जो है खाली भिंडी तोड़ने के खर्चे हो गए, इसलिए मैं परेशान हूँ।
Thank you for good presentation. No one is left now physically, so we have online. We have 3 more presenters.
One is
So one is Arjun,
Kapi Tala.
Gaurav is also there, then Kapi Tala and Srinidhi. 4 लोग हैं.
Who is there first? Kapi Tala. Mr. Kapi. Are you there? Kapi.
Yes, sir.
So share your screen.
Okay, sir.
And you have 5 minutes to 4 minutes.
Okay, sir.
Please.
Okay, sir.
It is physiological demand during fish harvesting. So just show the method, what you used, and
Okay, sir.
your data. Conclude. What is there?
Very good morning to one and all respected all the chairperson and member present over here. Myself, Kapil from Department of Agriculture Engineering of the Institute of Science and Technology. Topic for my today's presentation is physiological demand during fish harvesting in dairy farm fish culture in Zero Valley. Under the supervision of Professor K. M. Devangan. In dairy farm fish culture, this fish and dairy are grown together in the same field in the trench. These trenches are constructed in the paddy field, in the middle of the paddy field, to protect it from wild animals as well as to provide natural habitat for the fish during winter as well as in summer. In this, these fish are harvested 2 to 3 times annually. In this fish harvesting, minimum of at least 2 workers are required, in which as you can see in the picture, the person with the white shirt is the one who is pushing the fish towards the harvesting point. This is the harvesting point, and the person with the black, she is harvesting. She stands near the fence outlet and she harvests the fish. Though in this fish harvesting, majority of 4 tasks are involved, like placing of fish trap, releasing of water, pushing of fish towards the harvesting point, and harvesting of fish near the trench outlet. All these tasks are very physically demanding, and even all the tasks are very repetitive in nature, because farmers have to bend a lot since the trench that is lower than the field level. So farmers have to bend a lot, and they have to lift the fish from the trench and they have to put in the traditional basket. So in this, farmer experienced a lot of health problems. So based on that, we have selected Zero Valley as our study site, because in Zero Valley, paddy fish culture is practiced with majority. So from this Zero Valley, we have selected major villages like Hong, Harikula, and Hija for this study. And among this study, we have selected the female farmers, because female farmers are the major, they are the majority who works in the paddy fish culture. From this, we have selected 30 female workers, out of with age ranging of 21 to 68 years. And the criteria for selection of this subject was with experience of at least 1 year in paddy fish culture. From the selected subject, we have collected the heart rate measurement using the oral heart rate monitor M200 and H10. We have collected heart rate only for 2 operations, like pushing of fish towards the harvesting point and harvesting of fish near the trench outlet.
You come to results.
We have 4 tasks, like we have selected only these 2 tasks, because like these 2 tasks are the major problem which are faced by the farmers. And based on that, we have calculated the VO2 and ER. We have used the formula for calculating the VO2, that is 0.0183 HR minus 1.28, and for ER we have calculated using VO2 work into 20.88. And after that, we have categorized the work severity based on, as you can see in the table. With this, we got the result for pushing and harvesting fish. For mean heart rate was 62 for pushing fish, and for harvesting was 70. And for mean heart rate during work was 126 for pushing fish and 104 for harvesting fish. And mean heart rate was 141 for pushing fish and 127 for harvesting fish. And delta heart rate was 64 for pushing fish and 41 for harvesting fish. And also we have obtained the result for VO2, that is for pushing fish was 1.04 liter per minute, and for harvesting fish was 0.82 liter per minute. And also for energy expenditure rate, we have got
recording in progress.
21.63 kilojoule per minute, and for harvesting of fish was 17.02 kilojoule per minute. Considering all the heart rate, VO2 and EPR, we have concluded with the for both for pushing as well as for harvesting of fish. For harvesting of fish, it was classified as moderate task, and for pushing of fish, it was classified as heavy task. With this, I would like to conclude. Thank you.
Thank you. Any question from anybody? I have one point. Every one of you on ladies, they are using different equations for converting heart rate to oxygen consumption rate. Why it is so? Working at same place, why all 3-4 people are using 3 different type of equations for converting the heart rate to oxygen consumption rate? Population is same.
Sir, I have studied, I have familiar with this equation, so that's why I...
Same place, same set of workers, same laboratory. Why 3 types of equations are being utilized to convert heart rate to oxygen consumption rate?
Sir, I have studied and I am familiar with this equation, that's why I have this.
You convey this to Devangan.
Yes, sir.
Yeah. When the subjects are almost of the same place, they are all in and around Arunachal and Assam. These are very near, about 100 kilometers here. Same race, not different. So there should be only one equation for converting heart rate to oxygen consumption. You know?
So please
Okay,
take
sir.
care of all these things, and age group also, you should not take very elderly people because the VO2 max will change and then it will affect the results. Okay? So
Okay,
please
sir.
take care of these
Thank you.
things. So we have second presenter. Arjun, Arjun. Arjun Naik. Please say it again.
Srinidhi is there?
Arjun को जोड़ दीजिए.
Yes, sir, I am here, sir. Can I share my presentation, sir?
Yeah, please. Robotic pesticide applicator. Yeah?
Arjun?
Yes, sir, I am sharing, sir.
You have 5 minutes, Arjun, to complete your
Okay. Yes. Sir, is my presentation is visible, sir?
presentation mode में कर दो.
Yes, sir, कर दिया. Respected chair and co-chair and moderators and other speakers, we are very honored morning to one another. Myself, Modi Arjuna, PhD scholar at Division of Agricultural Engineering, ICAR, Union Agricultural Research Institute. My oral presentation is Robotics Pesticide Applicator for Greenhouse and Intervention for Enhanced Safety and Efficiency. As the greenhouse, the total area of the greenhouse cultivation was 5.6.
Mr. Arjun, please try to concentrate on the equipment which you have developed
Okay,
and
sure.
economic features you have measured. Okay?
Okay, sure. Sir, as compared to open field operation, greenhouse operations, especially during the spraying operation, there is a high chemical exposure and economic drudgery to the operator because the activity is repetitive arm movement and as well as there is a above shoulder height, working at above shoulder height. Due to this, we have measured two major parameters. One is assessment of potential thermal exposure and economic aspect of operator with different traditional sprayers, which are battery powered napkin sprayer and electric powered sprayer. And to mitigate these drudgery and chemical exposure, we have developed a low-cost robotic pesticide applicator suitable for greenhouse. And as well as the same developed robot can be also used for open field operations. Initially, we have investigated potential thermal exposure and economic aspect of operator with the two battery powered napkin sprayer and electric powered sprayer. In two application method, that is one is continuous flow method, in which operator moves in the crop, stays left side of the crop and returns in the same method. In case of alternate row, the operator moves to the next row and again comes to the same process, so that we will get some time to spray droplet to settle down. And these are the sequence of operation we have performed to extract the potential thermal exposure. After completion of activity, we have
Come to the data. How much you got? Thermal exposure. And which body part was involved?
Okay. To mitigate this exposure and drudgery, we have developed a robotic vehicle. This is the isometric view and the front view and side view of the vehicle, and this is a circuit diagram from the developed vehicle. And we also integrated a target specific spraying system based on the temporal variation of the plant, based on the spatial variation of plant type, it will spray the robot will spray this one. There is a variation of plant type within the limit of
Arjun, please hold on.
Mr. Chairman, sir, sorry to disturb you. After the end of this session, the next session is the theme session of the convention, and it is in the auditorium here only. So after this, there will be tea break.
Okay.
All the groups are there. All the groups. And this is the program.
Thank you.
So Arjun, continue and
Yes. So this was the developed robotic pesticide applicator. So there are sequence of sensors connected on the front side of a end of the nozzle. These sensors will detect the height of foliage in between the while moving in between the crop row, and based on the plant height, it will spray. Where there is no height detected by the sensor, it will won't spray. And also the robot was integrated with environmental monitoring parameters monitoring system as well as robot monitoring parameter system. As the robot can also be suitable for open field condition where there is a high temperature, humidity and wind velocity, that time it will automatically senses the microclimatic condition and warns the operator. As well as we also integrated the robot with normal clock detection.
Please show the video.
Please show the video.
Please show the video.
Okay, sir. The robot can also be modified like this, and we have incorporated a method called letter bank mechanism into the optical boost to convert the same greenhouse robot to suit for open field condition also, sir. This was the case, sir, we can do. And these are the different views of the developed CAD views of the developed robot. This one, sir. And these are the different applications we can do in open field and greenhouse conditions, sir.
Go ahead.
Sir, we measured parameters.
Please conclude results.
Yes, sir. Sir, we also evaluated for different strain nozzles and different speed of operation and distance between the strain nozzles from the target, sir. And sir, in terms of potential thermal exposure, we have observed that with the battery powered natural supply, continuous flow of application getting highest exposure, sir, 69.4 ml per hour, sir. That means if you apply if you work for a day, that is 8-hour working day, the operators are getting more than 500 ml per day, sir. This was with continuous flow, sir. If we introduce without any engineering intervention, we will follow just alternate flow measurements, we can reduce up to 16 to 25%. This was the different color chart showing that higher exposure is getting in the chest area, sir. These are the different economic parameters. We can see that with the spray application technique, we are not observing any changes in the economic parameters. With the type of spray used, we are observing changes in the economic parameters. These are the some robot performance parameters. The range of wireless communication and the electrical field capacity is 0.8 hectare per hour, actual field capacity and efficiency. And these are the results. And we also comparative economic evaluation were also developed, sir. The number of fields required to cover one greenhouse having a size of 60 to 25 meters, covering an area of 1500 meters square is getting three fields, sir, where compared to battery powered naphtha where it is 10 fields required, sir. Time taken to cover is 45 minutes only it will take to cover a greenhouse area of 1500 meters square with the developed robot. But with the battery powered naphtha we want to do the same thing in 4 hours it will take. And the developed robot having a payback period of 3.53 years and with backbone naphtha it was 1 year, sir. These are the conclusions. Potential thermal exposure depends on type of equipment used and application technique both, sir. It is depending on both, sir. And the upper and left half portion has significantly higher exposure compared to lower and right half portion of the body. Because the foliage is vertically spread, we are staying at above shoulder technique, getting upper portion of the body is getting higher exposure, sir. Implementing an alternate drop spraying technique resulting 16 to 25% reduction in exposure with the battery powered naphtha sprayer as well as with the electric powered naphtha sprayer, sir. The developed robotic sprayer can also be useful for open field condition, having a theoretical field capacity of 0.2 hectare per hour and actual field capacity of 0.15 hectare per hour with field efficiency of 75%. The cost of developed robots is around 1.2 lakhs with the total operating cost of 665 rupees per hectare with 3.53 years payback period. Thank you.
Thank you, Arjun. Any questions from the audience? Thank you, Arjun. You can.
One question about your sprayer.
Yes, sir.
How far it is away from your crop, the nozzle?
Sir, nozzle is around 30 centimeters, sir. We also provided a provision to adjust nozzle spacing from the target, sir, means from the foliage.
That is what I am asking. Whether the recommended is about 50 centimeter or so to get the complete spray, the pattern or the nozzle. You know? So you are going too nearer to the plant. So you will be having bigger droplets on the upper canopy of the plant. Okay? That will happen. If you measure, it will come. Or sometimes you will have completely wet leaves, which are very near to plant. So my suggestion to your design is, instead of having two booms on the either side, you have one boom, two booms expandable from the center. It expands according to the distance from the plant. Okay? So try with that. Thank you. Good job.
Thank you. Now we can have next presenter. Serenity is there. Serenity.
Okay. Next one, Srinidhi is there?
Srinidhi, are you there? Srinidhi? Gaurav?
Okay. Anybody else?
Yes, sir. Hello.
Anybody is available? Who wants to present?
Yes, yes, sir. I am Gaurav Chaudhary.
Okay.
Just given 3 slides. So share your screen and
Hello, sir. Am I audible?
Yeah. Please. Yeah, just
present your document. That's all.
Good morning, respected dignitaries. I am Gaurav.
So just give your highlights of the finding. It's a review paper, so just highlight the findings.
Oh, sir, can you again repeat? Can you repeat?
This is a review paper.
Yes, sir.
So my request to you is that just highlight the findings of your review. So just go to the concluded part where you have got what are the major findings.
Okay, sir. Result. Okay. Sir, actually in my result, I am getting that the design modification, like if we increasing the length of the feeding chute up to 100 centimeter and 65 centimeter of each cover, and the opening height if we increases up to 220 mm, and if we increasing the slope of feeding chute from 15 to 25 degree, it will reduce the injury significantly. And also we can use the sensor safety system, like we can use the PI and other sensor to detect the human limb if it's come in the hazardous zone of the feeding chute. So, and we can also educate or educate the farm operator and enforcement of the laws strictly in the ground. We can also decreasing the special injuries in the field, sir.
Okay, but is there any basis for recommending the change in the dimension of the soup?
Actually, sir, Indian standard is also IS 9020 also indicating that the shutter should be more than 900
So IS 9020, the lengths recommended were based upon the body dimensions of Indian person.
Yes, sir, yes.
Okay. So what is the basis of further increasing, whatever you are recommending, or you are saying that okay, this should be done? What is the basis of it? Whether we want to give additional margin or because there is anthropometric dimensions are more or less constant for the country. Okay?
Yes, sir.
So what is the basis? You are asking that okay, slope also has to be increased, covered area has to be increased. What is the basis of it? You have to come out with some justification for it. I am not asking you to do right now. Think over it.
Yeah, yes, sir, yes.
See, think over it and discuss into dynamic anthropometry. So once you done,
There you have to think about
space
it.
envelope changes. Okay, so this is what of service indicator.
And when you are working, how that dimensions changing. Okay, thank you. Done. Next.
Thank you, Gaurav.
Yeah, thank you, sir.
Anybody else? Online? Anybody online? Wants to present?
Anyone interested online to make presentation? If no, then can wind up. There is another program as indicated here. At 10:30 to 11:30 in ISA. This is in Golden Jubilee Convocation Hall. It's your turn.
नीचे आओ तो
So with this, we will close the session, and I'm really thankful to all the presenters for making great efforts to make an excellent presentation. I'm also thankful to all the attendees who are here, Dr. Mehta who would share his time, Dr. S.K. Singh, and Dr. Sanjay Kumar for organizing everything. And report here, Dr. Roth, Dr. Ismail, Dr. Sayyid and Dr. A. Agrawal for making the keynote presentation as well as co-chairing for the session. So with this, we'll wind up.
Thank you, sir. At the outset, I would like to thank both the chairpersons, Dr. Adarsh Kumar and Dr. K. Agrawal for chairing this session. So, it's a small amount of fun.
ये मोमेंट तो बहुत है इसके बारे में हम चर्चा करेंगे
Thank you, Manala, for giving me the opportunity to serve as a technical director. So this is the last session for me. Thank you, Manala, for choosing me as a technical director. So I did that last 3 years. Thank you for this. Thank you, sir.